Hello everyone, I am Vaishnavi Gedam. The topic of my seminar is silicon polymer. Let's take a brief idea what we are going to study here. Contents: Introduction, History, Production of Silicon, Preparation of Silicones, Structure of silicon polymers, Properties of silicones, and last, Uses of silicones. Let's first understand what are silicones. Silicones are synthetic polymers with a linear repeating silicon oxygen backbone or SiO-Si linkage. It is an example of inorganic polymers. They have general formula R2SiO by N. Like carbon, silicon is also tetravalent, but due to more electronegativity, it has low catenation character. Silicon has low catenation property than carbon. In all silicon polymer, Si atom is sp3 hybridized. Next, history of silicones. F.S. Kipling and Matt Sanders coined the word silicone in 1901 to describe polydiphenyl siloxane by analogy of its formula PH2SiC6H5 with the formula of ketone benzophenone PH2CO. Kipling was well aware that polydiphenyl siloxane is polymeric whereas benzophenone is monomeric. According to nomenclature of modern chemistry, siloxane is correct term while silicones is incorrect. Let's see how silicon is produced. Silicon does not exist on its own in the nature. It found bounded with oxygen in material like sand, granite rock, etc. Silicon producer reduce high-grade quartz sand to elemental silicon via carbon thermic smelting process. The overall reduction reaction can be represented as SiO2 plus 2C gives Si plus 2CO. This reaction occurs in electric furnace at temperature greater than 1400 degrees Celsius. Now we know how silicon are produced. Let's see how silicones are produced. The preparation of silicon polymer involved three main steps: preparation of silicon intermediate, hydrolysis of intermediates, and polymerization. First, preparation of silicon intermediates. The intermediates obtained are the various organic chlorosilanes, of which methyl, ethyl, and phenylchlorosilane are commercial significance, which can be obtained by following methods. First, by using Grignard reagent, second by direct method, and third by aromatic silylation. First, by using Grignard reagent, in this method, solution of silicon tetrachloride in dry ether is allowed to react with Grignard reagent, which is formed slowly into the reactor. Reaction: SiCl4 plus RMgCl gives alkyl trichlorosilane or RSiCl3 plus MgCl2. Example: SiCl4 plus MeMgCl gives methyl chlorosilane or MeSiCl3 plus MgCl2. Second, direct method. This method used for preparation of methyl chlorosilane. In this method, methyl chloride is passed through silicon powder in presence of copper as catalyst at 250 to 300 degrees Celsius. Reaction: methyl chloride plus Si gives primary, secondary and tertiary methyl chlorosilane, in which secondary methyl chlorosilane form in 50%. The above method is modified by using methyl chloride and HCl mixture react with Si in presence of copper at 300 degrees Celsius to form methyl trichlorosilane as main product. Reaction: methyl chloride plus HCl plus Si in presence of Cu at 300 degrees Celsius gives methyl trichlorosilane plus hydrogen gas. Third, aromatic silylation. In this method, the preparation of intermediate like aryl silicon halide may be prepared by the reaction of benzene and other aromatic hydrocarbon with chlorosilane at 250 to 300 degrees Celsius in presence of AlCl3. Reaction: C6H6 react with HSiCl3 gives C6H6SiCl3 plus hydrogen gas. Second, hydrolysis of intermediate. In this step, selenols obtained by the hydrolysis of alkyl substituted intermediate prepared in step 1, which on polymerization gives silicones. The following reaction shows us that the hydrolysis of X2R to Si gives selenols. Third, polymerization. When two molecules of silanols react, silicone polymer form by dehydration, and this process of polymerization goes on. Similarly, if we used an alkyl trichlorosilane which on hydrolysis trihydroxy derivative obtained which on polymerization gives highly cross-linked polymer, the reaction is given below. Shows us how cross-linked polymer are formed. Structure of silicone polymers. The structure of silicones may be ring, chain or cross-link as shown below. Next, properties of silicones. Silicones have a good water repellent property. They have high dielectric constant and good electrical insulating power. They are resistant to mild chemical reagent like acid, bases and many organic compounds. They have thermostability and they can withstand at high temperature. They are bad conductor of heat and electricity. Last point, uses of silicones. Silicones are useful as hydraulic fluid due to low temperature coefficient of viscosity. They are useful as lubricant and dielectric fluids. Silicone are used for preparation of waterproof cloth, boot and etc. Silicone also used as insulating material, surface coating reagent and etc. Silicone used for making paints and enamels. Silicone rubber is used in surgery. Silicone rubber also have been used to replace membrane which enclose the brain. Thank you everyone for listening to my presentation.